Thank you. Hi, everyone. I'm Soroush, and let's get it started. I'm going to focus on Kubeflow Pipelines. It is our product for helping developers go from prototyping to real production system. So the agenda for today is I'm going to give you an overview of our motivation and our approach for how we built Kubeflow Pipelines. And then I'm going to give you some of the examples of the problems that inspired Kubeflow Pipelines and what we heard from the customers and their needs. And last, I'll show you some of the features that Kubeflow Pipelines has currently and how you can use it. So let's go through the motivation first. So if you have worked on machine learning deployments before, you know that building and deploying ML models is hard and costly. In order to go end-to-end from grabbing the data to having the model serving and so on, there is much more than just building the model. So the problems that we see today in AI are at least 3 of them that we are trying to tackle is deployment, where there are different solutions for different frameworks, and each cloud provider might want you to use their solution for a specific AI problem. And then when you want to go to on-prem or switch between clouds, they usually break or they're not even supported. So the next one is finding talent and really using the talent's time effectively. ML expertise is not easy to come by, and you want to really use their ML expert time as efficiently as possible. And lastly, the ecosystem the problem with the ecosystem is that it is difficult to find and reuse what is out there. If you know that like a new model came out for image processing, for example, and you want to grab that model and use it in your production system, finding it and using it in your production system takes a lot of effort. So our solution to these problems, it is Kubeflow, reusable pipelines, and AI Hub. So I'm going to go through these one by one. So what is Kubeflow? It is built on top of Kubernetes to let you train your machine learning models. It has support for PyTorch, TensorFlow, XGBoost, and a lot of other popular frameworks. It also takes care of serving and so on. So it is more end-to-end. It has support for GPU and like multi-node training. So it can scale up or down depending on your problem. And you can run it on any Kubernetes pipeline, Kubernetes deployment. So if you have your own cluster at your company, you don't want to use GCP, great. If you have a Kubernetes deployment, you can install Kubeflow on top of it. But there is also GCP support. Next is reusable pipelines. The goal is basically enabling an engineer or a machine learning expert to not waste time on rebuilding and reinventing everything from scratch, but picking the pieces that were built before and really just reusing it and building it what they care about. So discoverability of like these reusable pipelines is the problem, and AI Hub tries to tackle that. AI Hub is a place where it is a product that Google has built that you can search for the type of problem you're trying to solve and find solutions that are already built for that type of problem, and very easily build your pipeline around those. So you can stitch them together and build your pipeline there. It is really fast and easy to use. there's a one-click installation for Kubeflow on GCP. So if you found something that you want to use from the AI Hub, you can easily deploy it on your GCP account, basically. And there is also enterprise-level sharing. So what I mean is that within your company, if you have built something that is interesting to other teams, other employees of the company, you can share that solution with the rest of the company. And also, if you want to share it publicly, you can also say, I want to share this publicly, so everyone can use it. So next, I'm going to talk about the type of problems that inspired Kubeflow pipelines. Let's say you have your problem that you're trying to solve. You figure out where you can gather the data types that you care about for this type of problem. You create your CSV file. You do your pre-processing of that file and have your Python for pre-processing. And then you have another Python file for training the model, and it will produce a model file. And you're trying to figure out how do you go from that model file to something you can have in the production. And soon you'll see there is more to that. Like once you go beyond the ML model, you might want to look at how the model quality changes over time. If you just put the model out, is the model still as performant as it was when you first deployed it? So there's monitoring. And then you think about, how can I continuously deploy this model? So with the fresh data that is coming in, I want to create a new model, push that new model to the production. How do I monitor new versions of the model? How do I scale the serving of the model so that if there's new traffic coming in, I can easily respond to that? When the new data is coming in, you want to verify the new data so that if there's a regression somewhere in the pipeline that produces that input data, you want to be able to cache that. So as you look into it, it can grow to really a hard problem. This is a tweet that talks about she developed the model in 3 weeks, but going to production system took almost a year. So what we hear from customers from different companies is that using these tools for workflow management, for pipeline management that are not built for machine learning, they have trouble applying it to machine learning because there are machine learning specific things. For example, you care about metrics in machine learning for each model that can be different. You care about experimenting with different hyperparameters, and different model versions are different. And there are things that are very specific to machine learning that you can't just use any pipeline management system. And if you don't have any pipeline management system, then your models might be working today, but as the data changes and the user behavior changes, the models become stale, and updating the model might take many, many steps. You might have to run few jobs manually to grab the data and train the model, and test, make sure it is actually performing as you expect, and then push it to production. And if you want to do it every week, it is a lot of overhead. And lastly, experimentation of different hyperparameters is difficult. There is no good way of tracking what was the hyperparameter that was used for this model. So if in the future, in a month from the time that the model was trained, you want to look back and see how was this model trained, tracking that and be able to reproduce the same model or change the model is difficult. And these are the kind of problems that the customers had. So that is why we built Kubeflow pipelines. So next, I'll give you an overview of the Kubeflow pipelines, the features it has. The first piece of it is orchestrating your system. Basically, in your pipeline, you will have different components that are responsible for pre-processing here, or transforming, training, and so on. And Kubeflow Pipeline is responsible for making sure that the dependencies are met, and it will execute the containers in the right order and takes care of distribution of them. You can also take a look at the trainer job and look at the metrics that it provides. So if you click on the trainer, you can see the ROC curve in this case that the trainer was providing. If it was a TensorFlow job, it will have a tensor board if you have used TensorFlow before. But if it is like XGBoost model, it will have its own visualization of its metrics. You can also look at the logs during training. If there was any like errors or something, you can take a look here, and the configuration that was used for the trainer. So as I said, a pipeline is basically a set of tasks, ML tasks, and we use containers to encapsulate all it needs to run, make the code portable and repeatable. A task can be run on a single machine or a distributed fashion, and Kubeflow take care of that. And there is a Python SDK that lets you specify the steps that your pipeline needs to run and the dependencies between the different steps. And it provides a way for you to say what are the parameters to these pipelines. An example of a parameter to a pipeline can be like hyperparameters for learning rate, or for the optimizer to use, or it can be the input files that you want to process, or what is the column in your CSV file that has the label in it. So it will be easier to reuse if you parameterize it. Here is an example of a Jupyter notebook that you have input your pipeline here. There is pre-processing, training and analysis, and prediction and deploy steps. And it is just as easy as like a few lines of Python code to build a pipeline and run it on a Kubeflow cluster. Next is how you reliably experiment, and you can rapidly change and develop your model. So the cycle for experimentation is basically that you you pick some hyperparameters that you want to try. Let's say I want to try 100 trees, 200 trees, and so on. And you submit a bunch of runs. You wait for the results. You get some outputs out of those results. And now you want to look which one of these runs had the best result, and maybe clone the best one, modify it, and run it again with different configuration, maybe slightly differently, and experiment and improve your model. So this is the UI for tracking your models. You can see that all the runs are grouped by their experiments. So if you're experimenting with like an image model, and like here there's a TFMA experiment, XGBoost train experiment, and they can have multiple runs. And these are previous runs that finished, and there is a currently running job here. And you can easily clone an existing run. So you open one of the runs, you see that it has a good ROC. You can click on the clone here, or look at the configuration. and create a copy of it. And when you create a copy of it, it will fill up the parameters that you provided, but you can update the parameters. So you say here, instead of like number of trees, 200, you want 300 trees this time. And it is just as easy to iterate on your model. So comparing between runs is very easy. It will give you, basically for an experiment, you'll see a list of metrics. And you can compare different runs and how they performed. And if you want to dig deeper into each of these, you can select, let's say, like 3 of them, and click on Compare Runs. And that way, you'll get a deep dive on those 3. How do they compare against each other? Yeah, you get the metrics, AUC, and so on. The last piece of the puzzle was sharing and reusing components. So as we said, we want to reuse and compose instead of re-implementing and reinventing everything. So in this example that we saw previously, these steps are actually coming from AI Hub. So once you found the right component that does what you care about, calling it in your pipeline is as easy as just calling a function in your Python code. And we find the containers that needs to run as part of this AI Hub component, and we'll add it to your pipeline, basically. Yeah, that's all that is. Yeah. Any questions now?
What is the backend for this? In which language?
There is a combination of. Oh, right. So the question was, what is the backend that this is implemented in? It is a combination of Kubernetes itself, and on top of it, so there is some Go and Python. And obviously, like the components that you call, it can be any language. And also, they can call other cloud services. So within your code, you can have a component that uses Dataproc or Dataflow for distributed data processing, or like you can use BigQuery and all that. Yeah, so like you don't have to use Python or Go or anything. As long as you have your code in the container, you can run it as part of this pipeline. Any other questions?
Thanks for the talk. So the notebook there was for dividing the pipeline.
Okay, over there, yeah.
Where does building images come into this? Obviously, you were talking about like, making everything a hyperparameter.
Yeah.
Like, how does it work? Like, actually iterating on the code, and how does
Yeah.
it fit into the
So there is some code that basically takes care of containerizing your notebook. So if your model is in your notebook, it will look at your state of whatever you have loaded in your Python, and takes a snapshot of that and put it in a container so you can run it remotely on a distributed system.
It's fair to say that this is a way to version all the different models and versioning also the input data sets?
Yeah, basically there's a versioning for models. Is that the question? Yeah, and like you can go back to a version of the model and see how was it produced and what was the configuration for that version.
So follow up to that, is it then possible to say sweep through some of the parameters and look at the effect that how the model will behave?
Sorry, I didn't.
Can you sweep through different parameters you showed at the very end, where you can compare different models?
Yeah.
And if I wanted to sweep through a parameter and see.
Okay, so hyperparameter tuning. Is that the question? So the question is there a way to basically try variations of different parameters and automatically find the best parameter settings, right? Is that?
Automatically,
Yeah.
yes.
So there is like a Katib library, I believe, that for hyperparameter tuning in Kubeflow. I haven't used it personally, but you can. It provides a way to say like these are my hyperparameters. This is the space that you are searching for, and it will do the like automatic search for parameters. Basically, it will not do like a linear sweep of the parameter, but it will try different experiments and different hyperparameter values and pick the best one, basically.
Yeah, I was more concerned to like performance. Say, for example, I wanted to find the minimum set of like input set that I can train on, right? So I can give it multiple training sets, sweep across that, and then see what my performance is. That's something I can't really do with
The question is, let me see if I can understand the question right. You have different sets of input, and you want to try them all and see which set of inputs provide the best model, or minimum set of the.
yeah.
So you can treat that as a hyperparameter to the model. So like you provide all the sets to the model, and then the hyperparameter that says how many of these use during training, for example. And it can be 1, 2, 3, 4, 5. Like if you have 5 data sets, and see which one provides the best model, or see all of them and see which one is acceptable quality for you, for example. Does that make sense?
Yeah.
Yeah.
I'll bring you the mic for a second.
So I quite understand how actually my code going to be embedded into the pipeline itself. Just correct me if I get it right. So you show these boxes, which is faces of my pipeline, and I can click on pipeline on some face, write code like using one of supported libraries, and it be wrapped into Docker container and executed from using pipeline or like.
So let me go back a little bit. These are components. So a component is when you have already developed your Python code and you have built a container and you expose it as a component to a pipeline. So there is support for pre-containerized code. So like if you have built your Docker container somewhere else, you can use it in pipelines. If you have your Python code somewhere else in this Jupyter notebook, you can say, create a container from that, and then create a component that calls that container. And that also works. So when you look at this pipeline, these are not. There is no way to edit this right now. Like you can't edit it at this stage because it is running. This is showing like a result of a run. Editing happens before you create a pipeline. You write your pipeline that calls a bunch of containers and so on, and when you run it, you'll get that nice graph, basically.
Yeah, so container needs to be built in advance by me or by
Yeah,
somebody
yeah.
else. Okay, got it. And the second question is, so how you manage input and output of the different phases?
Yeah. So like the API supports. So pre-processing is a stage here, and pre-processing has .output, so it can provide a single output or a list of outputs. I don't know if it is visible, but basically a component can have a list of outputs, and it can be used in the future steps of like other steps in the pipeline. So pre-processing takes some input and produces some output, and training takes the output from pre-processing, and so on.
I mean, let's say I have like several gigabytes of data. So let's say I have somewhere several gigabytes of data.
Okay.
And slicing somewhere on the cloud and specify input as a location of this file?
Yep.
Okay.
Yeah, so you pass in the, here you can see example of like a Google storage path as like one of the inputs. And the output of the each component will create a temp directory on cloud, and yeah.
What about if I deploy it on-premise?
So the, Kubeflow will have different like deployment environments, and each environment can say like this is how you create a job and how to create a temporary and so on. So even on-prem, you don't have to use GS. You can use anything.
I'm pretty new to this one. I was going to ask, where is the container here? Like, is there a reference to the container?
So in here, we don't have any container here. This is just using some components that are predefined. And these components, if you look at the definition of them, some of them are coming from AI Hub, but the ones that are not coming from AI Hub are defined in the same. I don't know if I have any example of that in the slides. Let me quickly go back and see if there's any. But basically, we will say, this is the container name, and
You have to specify it. Some other example.
how do you specify it?
When you create component, you just you provide some configuration. You specify the image name, you specify the command line.
Yeah. Like this is open source, by the way. You can go through the examples. There are some samples for different like XGBoost, TensorFlow, and so on. And I encourage everyone to take a look at the Jupyter notebooks. There, in the notebooks, they're using containers. So you will see some example of that.
Okay, so one question I had is, so once you've trained your model, it outputs some artifact. How does it get into, how do you serve it? How do you transition from one to the other? Does it get packaged into the image, or is it through something like S3 or cloud storage and pull it later?
There are, for serving, there are components that are in charge of serving, and they are model specific. So we have developed serving a stack for XGBoost model and TensorFlow model. And I believe PyTorch is coming. I don't know exactly where it is, but basically there are reusable components for serving as well. And you can say this is deploy for TensorFlow. So it will assume that the input is a TensorFlow model, but there is a deploy for XGBoost and so on. So you can say deploy this model. And is that answering the question?
I guess so. We use SageMaker at the moment, and it kind of by default.
Sorry?
We use SageMaker
Okay.
at the moment, and by default it like tars up the model artifact and puts it on S3.
Yeah.
We have to then load it in, and it's like it's a defined format that they kind of force us to use.
Yeah.
Something like that.
The difference here is that there is no like internal format here. There are components that provide like XGBoost models, and there are components that serve XGBoost models. You can basically build your pipeline stitching these together.
Hi. If I want to automate the deployment to prod, is there a way I can run regression tests in this pipeline?
So there is a validation of the models, for example. You can say if the model quality is not as good as yesterday, or compared to yesterday, the model quality is dropping by this much, don't push to production. Regression, like unit tests are not supported, but some sort of like continuous automated pushing and validation of the model is supported.
Are you in production, and do you have a production roadmap?
So the question is, are we in production, and do we have a production roadmap? So currently, it is an open source project built mostly by Google, but there are partners that are putting components in the AI Hub and so on. So you can use it on-prem or on Google Cloud or anywhere you have Kubernetes. But we are planning to do a hosted service for this as well. It will be just a managed service, but same features. So. Yeah, you had a question?
Databricks has something similar called MLflow. Have you compared this to their project and what the differences are?
I have not. Is it? I guess. Is it supposed to like be end-to-end and so on?
And it helps you track your runs and your hyperparameters.
Okay.
Yeah, it's not in 1.0 yet. I think it's at 0.9.
This is also not in 1.0. Like we started. So Kubeflow is a bit older, but Kubeflow Pipelines is a next iteration on that, and it focuses on reusable pipelines and AI Hub and so on. So that is relatively like less than a year old, I would say.
I'll take a question on MLflow. So we recently got quick audit on that. And so that's more a productivity tool. It's not a tool that you use to build pipelines.
It's not for deployment, but it's for tracking.
Exactly.
Okay.
For tracking, making sure you have parameters handy for all the runs that you have, for the different experiments and so on.
Results.
Do you have a question? Okay, sorry. Never mind. I thought you have a question. All right, I think that's it.